That's no good. Well, hello everybody. Can you see me?
Yes.
Good deal. Is anything new going on with anybody out there? Hmm. Alrighty. Got a haircut today. Jeez. Went up in price again.
And I'm caught. I watched the last week's lecture too. I'm caught up.
Erica,
Yes.
let me look here. Are you doing good, Erica?
Yeah, a little tired, but I'm good.
So are you here today?
Yeah.
Just kidding. Amanda, are you here?
Yes, I'm here.
Look at you, KLM. Gotcha. Dylan? Dylan, did I get your homework finally? I did, and I got it, and it was really good. So I got it. Emma.
Yes, I'm
Yeah.
here.
How are you doing, Emma? I hope you're good. Gabriel.
Yes, I'm here.
Okay. Now, if you are here and you don't have a grade posted in eCampus, you need to let me know because you should have a grade. Let me go to the next one. Holly, you're here. I guess Holly's here. Maybe she's not. How about Hunter? There's the Hunter. We got a hat on today. All right. Indira,
Hi, I'm here.
are you doing good?
A little bit tired.
Yeah, we are. Jamie Anderson. Nikki.
Here.
All right, Nikki, good for you. Lillian.
Hello. Hi, I'm here.
Okay. Oh, let's see. Monica.
Here.
Gotcha. Reba.
I'm here.
Rebecca.
I'm here.
And Rosio.
I'm here.
You guys sound like you're just, but you guys should be happy as can be. I mean, Ryan, are you there?
Yes, I'm here.
So Ryan, are you happy?
Yeah, I'm having a good day. What about you?
Well, you should be really happy. Sharon, what about you?
Oh, I'm good. Thank you.
Vanessa, how about you? Vanessa. Vanessa Cantula. Gotcha. So why should everybody be happy? What happened yesterday?
The Cowboys won.
Yes, the Cowboys won. Usually people are happy after that. So let me check here on my Periscope. Is Alexa here? No Alexa. How about Marissa Flores? No Marissa. Alma Garcia. Alma. Gillis's. Jordan Guerrera. See who else I might show. Edith Narrow. Edith, are you here? Nope. Venancio. Joshua, my fisherman guy. Okay, I got everybody here accounted for or unaccounted for. Let's see if I can get to the book. Let's see here. And today is zeros and polynomial functions 3.4. Let's see, supposed to be coming up. I'm clicked on the book. The book is trying to focus in and get here. And it's giving me the chapter, but we need 3.4. 3.4 is coming into focus. Let's see where we are here. I think you guys should be able to see it right now. 3.4. Anybody?
Yes, we see it.
Yes, we can see it.
Good enough. Now, zeros of polynomials. Before we go any further, I want you all to understand what they really mean. So if I draw a graph that looks like this, and this is my x, and this is, let's say, a point, and let's say that's 3, 0. Here's my y. Say this is negative 3, 0. I didn't do that. The zeros are where it intersects the x for the x-intercepts, and this is the y-intercept. You're trying to find these points on the graph. Now, if I give you this equation, gosh, x squared plus and this is equal to f of x. F of x is technically what? What does f of x really mean, class? Somebody out there knows.
Why?
It's y. Now, if I give you x is equal to 0, or let's say yes, what is y then equal to in this case?
One.
Exactly. And that would be the y-intercept. Why? Because the x is 0 and it only hits the y and 1. Now, everything we're doing today is based on this concept. The x-intercepts and y. Now, let me prove this. Let me graph x squared plus 2x plus 1 and show you what? My calculator went away. Let's see if I can bring it back. Let's try it again. All right, so hopefully you can see the calculator now. Can I get an amen from anybody on that?
We see it.
Okay, good deal. I'm going to put in this new equation. We said x squared plus 2x plus 1. We said that the y-intercept would be 0, 1. Why? Because the x is 0 and we end up with a 1. Let's see if that's so. Here it is, 0, 1 right here. All righty, so we proved that. We're good. Now let's go back to the book. Using the rational zero theorem, list all possible zeros of this. Now, the number of zeros that exist are the factors of the constant term, that would be 4, divided by all the factors of the leading coefficient of the highest exponent. What does that all mean? The constant term, and this is 4. All the factors are 4, plus or minus 1, plus or minus 2, plus or minus 4. That's your numerator. The denominator is the leading coefficient. This is 1. So it's plus or minus 1. It looks like this. You get plus or minus 1, plus or minus 2, or plus or minus 4. Those are all the possible factors. Now, there's another rule. That the number of factors is maxed out by that, but can be decreased by numbers of 2. All right, we need to just look at one more. Number 2. This one's on the test. So the number of possible factors are the constant, you have plus or minus 1, plus or minus 2, because those are all the factors. But over 15, which is plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. What you're doing is finding all the factors of 15. Now, so you have plus or minus 1, plus or minus 2, 1 over 3, 2 over 3, 1 over 5, 2 over 5 plus or minus 1 over 15, and 2 over 15 plus or minus. Let's just see. How many possible factors do you see there? Can anybody tell me? How many possible factors are there?
I just see one.
It's all those in the blue bubble. How many are there?
Oh, the blue bubble.
Four.
How many possible factors are there?
4.
No.
3.
You have plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 2/3. Oh, you're looking at example number 2, right?
Oh, okay.
How many are there then? Anybody?
8?
There's
8?
6.
Yes.
16.
Finish.
16.
Yeah, there's 16. Golly, they're right there. They're listed right in front of you. You guys can't even count them. So how can you know what I'm even talking about if you don't even know that? Now, on the test, they're going to give you a problem like this. They're going to say, list all the possible factors.
Well, I'm kind of confused how they got the factors.
How do you get them? What was the rule? What are you supposed to do? You take, in this case, the constant term. What's the constant term in example 2?
It's -2.
Okay. How many factors are there? What numbers can you divide evenly into 2? 1 and 2. And that's your numerator. So you got plus or minus 1, plus or minus 2. That's the numerator. The denominator is all the factors of the leading coefficient of the x cubed. 1 goes into 15, 3 goes into 15, 5 goes into 15, and 15 goes into 15. Those are all your denominators.
Okay, I get it. And then so it'd be, yeah, the 4 and the 4. Yeah, 16. Okay, I get that.
Now, let me just give you a little trick to this. On the test, you're going to have to do a problem like this. And the book almost always uses plus or minus 2 or plus or minus 1, even though they have all these fractions. Now, once you find that one, you can get the other ones. There's a trick to it. So, what are the possible zeros for number 3? What is the numerator going to be? What number do we use to calculate them with?
Is it for checkpoint 2?
No, we're doing example 3.
Oh, 3. Okay, so
What number do we use to calculate?
it's 1.
No, the numerator. What's the numerator? You're not going to get this on the test.
I don't know.
No one knows. Wow. Hey, a lot of people do some homework. Here's the problem. It says it gives you x cubed plus 2x squared. Let me make that better. Now, on the top, What number do we use for the top? We use the -6. All the factors of it are 1 plus or minus, 2 plus or minus, 3 plus or minus, and 6 plus or minus. All those numbers go into it evenly. What number do we use for the denominator? Anyone?
1.
Mm-hmm.
Plus or minus 1.
2, 3, and 6.
We get the 1 from here. So you have plus or minus 1. So how many total factors are you? You have 1 over 1, 2 over 1, 3 over 1, 6 over 1, all plus or minus. How many factors do we have to consider here?
8.
Exactly. We have a total of 8 factors. You have to do what I just showed you. You've got to be able to take a problem and tell me what the factors are going to be in this class and on the test.
How did you get 8 though?
Plus or minus 1 is 2. Plus or minus 2 gives you 4. Plus or minus 3 gives you 6. And plus or minus 6 gives you 8. Does that not make sense, Lillian? Hello?
Not really, not to me, no.
How many numbers is plus or minus 1?
Just one number.
No, it's 2. You got a plus 1 and a minus 1.
Oh, okay.
How many numbers is plus or minus 2?
2.
Yeah, and then how many numbers are plus or minus 3?
2.
And 6 is the same way, so you have a total of 8. Thank you, Sharon. Okay, so this is what you have to be able to do. And you guys got to look at this stuff. Now let's go to the page and see. There they have plus or minus 1 plus all over that, so you get a total of 8. Now, you want to test to find which one is a factor. Well, you can test the one. Look at test 1 using synthetic division. How do you get the synthetic division? Well, the equation x cubed gives you 1 in front, 2 is the second digit, -5 is the third, and 6. You can see test 1, bubble 1. And if you're using 1 as a possible 0 and use synthetic division, you have a remainder. So it's not a 0. It's a 0 only when there is 0. And I said you always want to try 2 or -2. Look at 2. Test 2. Bring down your 1. 2 times 1 is 2. 2 times plus 2 is 4. 2 times 4 is 8. 8 minus 5 is 3. 2 times 3 is 6. And 6 minus 6 is 0. It's a 0. Now, let me show you what this means. Hopefully, this will make sense. I'm saying what I hope it does. I want to show you the thought process so that you can be successful with this. Okay, so I'm going to explain the whole thing. I'm going to do it manually, and hopefully this will help you. So they said find the zeros for this equation. X cubed plus 2x squared minus 3x minus 6. And we did all those things. We found that plus or minus 1 was a possible factor, plus or minus 2, plus or minus 3, and plus or minus 6. So they tried 1 and failed, but then they tried 2. Now, if you're using synthetic division, you're using the leading coefficient. So have a 1 for the x cubed, a 2 for the x squared, a -3 for the x, and a -6 for the constant. What number do you get? We're going to try 2. Using synthetic division, you bring down your 1. 2 times 1 is 2. So 2 goes here. You add them, you get 4. 2 times 4 gives you 8, leaving you 5 here. Oh, wait.
That's right.
No, something's not right. I've got something wrong. Let's see. 1.
Oh yeah, you have to put -5x over there, I think.
This is supposed to be a 5 up here?
Yes, sir.
Yeah.
Yeah, that's what I thought. And this then becomes a 3. Perfect. Then 2 times 3 is 6. That gives you a 0. Now that means x minus 2 is a factor. Now you're down to a square. This reads 1x squared plus 4x plus 3. You can factor this using FOIL. That gives you x plus 1 times x plus 3. That gives you a -1 as a factor as well as a -3. If that's so, what we did is we found the 2 was 1. That means -1, -3 is also. I'm going to write this again. And in this spot here, if these are possible zeros here, I'm going to put in -1 here and see what we get. I'm going to change this 2 out and put in -1. I'm going to rewrite it. So again, we have x cubed plus 2x squared minus 5x. I don't know how I got 3x. I'm just writing this bad, I guess. That's an x. And then minus 6. In synthetic division, this is a 1, a 2, a -5, and a -6. And we said we're going to try a -1 because it shows it was a 0. So we bring down our 1. -1 times 1 gives you -1. You add them, you get 1. -1 times 1 gives you another -1. -1 and a -5 gives you -6. -1 times the -6 gives you +6. It's a 0. So that tells you x minus plus 1 is a factor. Because that's how you get the -1. That gives you 1x squared plus x minus 6. If you factor that, you get x plus 3 times x minus 2. That gives you the other factor of -3 and a +2. And that's what we said we found. This is really critical. So if you look at this page, once you found the 0, and notice if it's a 2, then it says here, thus x minus 2 is a factor. You can find the other ones by using FOIL. This is the one you should practice right here for the test. Number 4, finding the zeros of this polynomial. Again, the constant gives you plus or minus 1 or plus or minus 3 at the top. In the bottom, you have plus or minus 1. So you have a total. How many possible factors to consider? How many possible factors in number 4? Somebody out there knows. Come on.
Uh, 4.
Yeah, exactly. It says you have plus or minus 1 or plus or minus 3. Goodness. We're going to be here all night. And so you try one of them. Let's look at the next page. So look at 1 didn't work, -1 didn't work, 3 didn't work, but -3 works. And once you get that, you get x squared plus 4x minus 1. Now notice that nothing factored, FOIL does not work for that. So they have to use the quadratic equation. Look at the top right there. It says you have x plus 3, x squared plus 4x minus 1. So one of them gives you -3, but you got to factor out the x squared plus 4x minus 1. So you got to use the quadratic equation. You got to plug in the a, the b, and the c. The a is 1, the b is 4, the c is -1. So once you plug all those in, you end up with -2 plus or minus square root of 5. You should be able to do this because they will also do one of these on the exam. They're going to ask you to do this. Now, how do you tell what is the a, the b, and the c? So you have there x squared plus 4x minus 1.
Well, the x squared is a, 4x is b, and 1 is c, right?
Not quite. What's c? When they got the solution, they said -3 was a possible 0. So that means x plus 3 is a factor. They left with x squared plus 4x minus 1, I think, right? Let's take a look.
Okay, so -1 then.
Yeah, let's take a look. There it is.
Okay.
X
I
squared
thought it said
minus 1.
plus 1. Oh, it's a negative.
You
Yeah,
just-
so it's a -1.
Okay, so now, if you're going to use the quadratic equation, for this problem, you got to identify the a, the b, and the c. The a is in front of here. That's your a. Which in this case, a is going to equal 1. This is your b. And the b in this case is equal to 4. This is your c. And c is equal to a -1. So in the equation, b squared minus 4ac all over 2a. So it's a -b plus or minus the square root of b squared minus 4ac over 2a. You got to plug these parts numbers into the puzzle. And you have your calculator. And that's what they did. So go back to the book. And look. -b would be what? -4. Plus or minus b squared, that's 4 squared, and so on. And you got to be able to do it. Now, example 5. Notice they're missing a cube. So if you're going to do any kind of division, first of all, the possible zeros, you got 24 on the top, or you have 24, you have plus or minus 1, 2, 3, 4, 6, 8, all were plus or minus 1. I don't know how many, 2, 3, 4, 5, 6, 7, 8, 16 possible zeros. Now, I always told you to try 2 and using synthetic division. So now look, you have a 1 for the 4. You can see they have that as a 1 right here. There are no cubes, so you have to use a 0. Then you have a -6, a -8, and 24. And then they have with a 0. Now, what it does is shrinks it to a cube. You can see you've got a cube. Then you got to use synthetic division again. So for the cube, you have a 1, 2, -2, and -12. And they got 2 to work again. Now notice this is pretty cool. 2 work twice. What does that mean? 2 work twice.
That it was 2.
What does it mean? If you had x, come on, machine, x minus 2, that gives you 2, and another x minus 2. You had 2 twice. What does that mean?
So that's the ordered pair, 2, 2.
X minus 2 squared.
It's a square. And anytime you have a square, it touches. So we have a fourth. We have 4 powers. So let's graph this thing. We know at the point 2, it's going to touch 2, 0, because it says so. So let's graph this thing just to see what really happens. So we have to write down the problem, or at least I do. So I can show you how to, you can always graph it. So here we have the problem. X to the 4th minus 6x squared minus 8x plus 24. As long as this thing is equal to f of x, and f of x is y, we can use our calculator without manipulating it. So we're going to go to our calculator. We're just going to put it in our calculator. That's all we're going to do. And it'll give us all the same stuff. Boom. Calculator's on. I'm going to go to y equals. I'm going to clear that out. I'm going to put in the problem. X to the 4th. Boom. Push it out. Minus 6x squared. Push it out. Minus 8x. And then plus 24. We're going to ask it to graph it. Let's see what happens. Look where it touches. So this is pretty cool. This is just the whole graph right here that you see. Okay. Let's go back. Back to the book. And look at this one. Well, let me start from scratch here. This is what we saw in our graph. There is other stuff that comes out. But I want you to see this. Look at the calculations in front of you. When you end up with an I, an imaginary number, that means there are no other possible zeros because they're imaginary. Now, how can that happen? Let me make it very easy for you to see. Remember, a 0 is something that goes to the x, and then you also have the y-intercept. But let's look at this. Let's draw a graph. This is, of course, our x. This is, of course, our y. What if we have a graph like this? It does not intercept the x. Therefore, it's imaginary. That's how that can occur. That's all they're saying. Now, The last problem for the night is I want to work this for you. One second. It says the fundamental theorem of algebra says that if you have one imaginary root, they call it a complex root, that you really have to have two. So what does that mean? Let's say we have this. If we have 6 plus 2i, and this is one root, the other root must be 6 minus 2i. That's the rule. Or make it even simpler. If we have 2i, what must the other root be?
Negative 2i?
Exactly. Now, what that would mean, it would look like this. X plus 2i and x minus 2i. Those are your imaginary roots. Again, on the test, they're going to say, okay, 1's a root, 2's a root, and 3i is a root. But there are 4 roots in this system or in this equation. What is the 4th root? What would you say?
Negative 3i.
Exactly. And that's one problem on the test. That's simple. Now, back to this part of the problem. Now, this is the problem I said I want to do the last one. If you read this problem closely, it says it's a 4th degree polynomial. So that means you have something to the 4th power. It says you have roots of x minus 2 and 2. They say f of 3 equals negative 150. They want you to figure out what the whole polynomial is. And it's simple. It looks hard, but it's not. So I'm going to flick back and forth to this. If you write down, they have roots of negative 2 and 2. If you write down that there is an I, and it's a 4th degree, and f of 3 negative 1, we can solve this entire thing. So let's look. Let me make it make sense to you, and we'll come back a couple times to help it make sense. So number 1, it's 4th degree. That means there's 4 possible roots. They said one root for sure was a negative 2. So you have x plus 2 as a factor because that gives you the negative 2. The other one they said was a positive 2. That gives you x minus 2. They said one of the roots was I. So you have x minus I. But it's a 4th degree. So what's the other root that we don't have here?
X plus I.
Exactly. X plus I. You have a leading coefficient of this whole thing. We don't know that, so we'll call that n. We know that if we put in f of 3, that all this will give us negative 150. Now, we can multiply some of this stuff out. Let's take a break from this. We won't lose it. Let's go back to the book so this can hopefully it'll start making sense. Look at under the solution, look at line 2. You have a to the n, x plus 2, x minus 2, x minus I, and x plus I. They multiply all that out. So x plus 2, x minus 2 gives you x squared minus 4. X minus I times x plus I gives you x squared plus 1. Why? I times I is a negative 1, and it's made negative, it's positive. So if you're not clear on that, you should study it. So we have a to the n, x squared minus 4, and x squared plus 1. Now, again, if you have any questions about that, we'll look at it again right here. If you multiply these two out, you get x squared minus 4. If you multiply these two out, you get x squared plus 1. Why? Because x times x gives you x squared. The middle term's a negative xi and a positive cancel out. So then you end up with a negative I times a positive I. I times I gives you I squared. I squared is a negative 1, but you have a negative sign in front of it, so it makes it a positive 1. Now, n we don't know. And we're still doing f of 3. Now, what that means is this. X is 3. So everywhere there's an x, if we put in 3, we're going to get negative 150 here. So you have 150 equals n times 9 minus 4 is 5, because 3 squared is 9 minus 4 is 5, times 10. 3 squared is 9 plus 1 is 10. Now, this gives you negative 150 equals n times 50. If we want to get n by itself, we're going to divide both sides by 50. Divide this side by 50, it goes away. The other side gives you negative 3. N equals a negative 3. So if we write this whole equation in again, we just have to put a negative 3 here. And that's the equation. Or you can put it here, negative 3. And let's see what the book says. On the next page. Again, look, they multiplied. Oh, they did it even a different way. They had an extra 4 minus 3x squared. They just went with the original equation. They put 3 in there, so you got 81. I did it kind of, I think, the easier way. Then they end up with 50, n equals, end up with negative 3. So the equation looks just like you see there. Oh, you guys have made a mistake. I got to show you one thing else. I'm sorry. I forgot to tell you about the Descartes rules of signs. That's on the test. Otherwise, I wouldn't do it. There are 2 rules for Descartes rules of signs. One rule is the positive number of possible zeros if x remains 1 is the number of sign changes. So look, you have positive to negative, you have a negative to a positive, and a positive. So 3 sign changes. So the rules are they're either 3 or 1 or 0. The rule is you always decrease it by 1. Now, that's how you determine the positive ones. How did I do the positive ones? I put a positive 1 for all the x's. Now, the negative zeros is if you put a negative 1 in for it. So let's look at one. Look at this one, x cubed plus 2x squared. So if you put in a positive one there are no sign changes. So the possible zeros, there are none because there's no sign changes. Look at the solution. Thus, there are no positive real zeros because if you put 1 in there for x, all the signs remain positive, so there's no possible zeros that are positive. Now you put a -1 in here. Look what happens when you put a -1 for x cubed. It becomes negative, and the other one, it stays positive because it's a square. The next one becomes a negative because it's a single x. Then you have 4, so count the sign changes. 1, 2, 3. The only possible zeros are -1s, and you have either 3 or 1 or 0. Notice they say 3, then they write -2 or 1. That's it for today. Those are Descartes' rules of signs. We'll go one more time over it during the review. But we had a lot of stuff tonight, class. This is just one section. A lot of stuff. Let me go through my book here of who's here. Again, I keep track of all this stuff. Let me just call your name. But first, let me see if somebody's here that I didn't have. Did Lexa make it in here? No, Lexa. Marissa Flores, Alma Garcia, Jordan. Edith. Let's see. Devionia Robinson. No, that's right. Joshua, are you here? My fishing guy. Shimini. Nobody came in. So Amanda, do you have any questions? You're free to go if you want.
Thank you. I'm good.
Dylan. Okay. Emma.
I'm okay, thank you.
Erica. Gabriel.
I'm okay. Have a good evening.
Good night. Gabriel.
All is well. You have a wonderful night.
Thank you. Holly.
I'm okay, thank you.
Indira.
I'm okay, thank you.
Good night, Indira. Jamie. Nikki.
No questions, thank you. Have a good night.
Lillian. Monica.
Thank you.
Monica, are you there? Reba.
I'm good, thank you.
This is
Okay.
Monica. I'm good. Thank you.
Rebecca.
I'm good, thank you. Good night.
Good night. Rosio.
I'm good, thank you. But I won't be available on Wednesday to join. I'm gonna be in a corporate meeting, but I will watch the recording.
Okay, Rosio. How about Ryan and Sharon?
Yeah, I'm good. Thank you.
Hunter, you're free. Thank you so much, Hunter. I appreciate you. Thank you, guys. Good night, everyone.